In this video, I am going to solve the third question from chapter 27, circuits. Okay. What is given in the question? We have to read a line by line. In the figure, the ideal batteries have EMF E1 12 volt and EMF E2 equal to 4 volt. So if you see the circuit diagram, we have two EMF. What are they? E2 and E1, and E1 have 12 volt and E2 has 4 volt, right? So better I can write what is given in the question. So E1 takes the value of 12 volt, that means EMF 1, and EMF 2 have 4 volt, right? And also we have the resistors, two resistors we have connected in the circuit, am I right? So that means R1 takes the value of 4 ohm and R2 is 8 ohm, right? Now by using these values, we are going to answer 7 questions. So let's read one by one and let's answer one by one. Clear? Okay. What is given in the first question? What is the current in the circuit? If you want to find the current in the circuit, we have to frame the equation. How to frame the equation? We already deal the similar type of question in the previous video, right? So in the similar way, we are going to frame the equation. How to frame the equation? We have to use a loop rule, Kirchhoff's voltage rule, right? So here, the most important thing, if you want to use the voltage rule, first of all, you have to see the circuit is a closed loop or not. So if you see the circuit diagram, it is perfectly a closed loop, right? Am I right or not? Everything was locked perfectly. It's a closed one. So if the circuit is closed loop, we can easily use the loop rule because Kirchhoff's voltage rule has the another name as loop rule. Clear? Okay. How to frame the equation? And in the previous video, I told how to frame the equation. If you have a multi EMF, that means here in this circuit diagram, we have two batteries which has the different EMF value. So what you have to do, first of all, you have to separate EMF one side and you have to separate the product of current and its resistance one side. So now what you have to do, first of all, you must know what is the direction of the current. So what I told in the last video, if you want to know the direction of the current, you have to give the importance for the strongest EMF battery, right? So if you see this battery EMF, our EMF first battery has 12 volt. So that means we have to consider the direction of the current is flowing from E1, right? Why? Because this takes the value of 12 volt. So I'm going to consider the direction of the current is in this direction. Clear? Clear? Understand? Okay. Now we are going to frame the equation. So I'm going to separate EMF one side. I'm going to separate the product of current and its resistance one side. So how we can write? So in this diagram, our E1, that means the EMF 1 is the strongest one. So I have to take that as a positive value. But the second EMF, see, it is moving in this direction. Am I right? Because the positives, the current will be in this direction. So your second EMF will take the negative values. That means the EMF 1 minus EMF 2, which is equal to this current is passing through R2 and this current is passing through R1. So how we can write? I multiply by R2 plus I multiply by R1, right? That's it. Once you frame the equation, the rest of the things are very easy, right? We are going to find what is the current in the circuit. So what we have to do, we can take the current as a common term in the right hand side. So I, which is I multiply by R2 plus R1, and left hand side EMF 1 minus EMF 2, and we are going to find the value of current. So I'm going to keep this current here. I'm going to move this R2 plus R1 to the left hand side of the denominator. By that the equation become I, which is equal to EMF 1 minus EMF 2 divided by R2 plus R1. Now I'm going to substitute the value because we have all the values in the question. What is the value of EMF 1, which is 12 volt? The EMF 2 is 4 volt divided by the value of R1 and R2 is 4 and 8. That means the second resistor is 8 ohm and the first resistor is 4 ohm, right? So now we have to calculate the value. So 12 minus 4 divided by 8 plus 4. So what's the answer? So 12 minus 4 over 8 plus 4. The answer is 0.667 ampere. So what is the current in the circuit? The current in the circuit is 0.667. So that is the answer for the first question. Clear? Clear? Okay. What is given in the second question? What is the dissipation rate in resistor 1? So we are going to find what should be the power. When the current is passing through the resistor 1, what should be the power value? Likewise, in the third question, what should be the dissipation rate when the current is passing through the resistor 2? As I already mentioned, we have three formulas for the power. In the previous video, I mentioned the power, but no problem. I can just mention the formula again. So what are the formulas? We have the formula P, which is equal to EMF, the current multiplied by EMF. And we have power P, which is equal to I square multiplied by R. And also we have another formula, which is EMF square over R. So these are all the three formulas we have for power calculation. Now in this question, that means the second subdivision question, we are going to find what should be the dissipation rate if the current is passing through the resistor 1. Am I right? So that means we are going to deal with this equation because the current, they are telling about the current related with the resistor. So if you see the first one and the second one, it is not. So in the first part, you have the current multiplied by the EMF. In the third, you have the EMF square over resistor. That means the first one and the last one is not applicable for the second part. So what we are going to do, we are going to find the dissipation rate. What is the dissipation? The dissipation means it says about power. So for resistor R1, what is the value of R1? The value of the resistor 1 is 4 ohm. Am I right? So better I can write the value one more time. The R1 is 4 ohm and R2 is 8 ohm. So the question is related with the resistor 1 only. So I'm going to deal with this formula. Therefore, power P, which is equal to I square multiplied by R1. So I'm going to substitute the value of the current here because in the previous part we found the value of the current, which is 0.667, which is square multiplied by the resistor 1 value is 4 ohm, right? 4. So what should be the answer for the first power for the resistor 1? So 0.667 square multiplied by 4. I got the answer as 1.779. So I can write the answer as 1.78 watt. Clear? Likewise, you have to find the dissipation rate if the current is passing through the resistor 2. So that is our third question, right? So what is the third question? For power calculation for resistor R2. So we have the rule P, which is equal to I square multiplied by R2. So the I value is 0.667 square multiplied by, what is the value of R2? The value of R2 is 8 ohm, right? So what should be the value? 0.667 square multiplied by 8. I got 3.559. So I can write as 3.56. 3.56 and the unit is watt. Clear? This is the answer for the third part. Okay, let's go for the fourth subdivision. What is given in the fourth subdivision? In the fourth subdivision, what is the dissipation rate in battery 1 and in battery 2? So if you want to deal with the battery, if you want to find the dissipation rate related to the battery, Again, we have to use this formula. Which formula is exactly applicable? We can't use the third one because this question is related with current and the battery, right? So I'm going to deal with the first equation, which is P, which is equal to I multiplied by EM. Clear? So for the fourth subdivision, energy transfer rate, which is the power, right? Energy transfer rate for better I can write it here. Energy transfer rate in battery 1. So what's the formula? Power P, which is equal to I multiplied by EM of 1, because we have 2 EMF and the question is related with what is the energy transfer rate in first battery. So we have to write the value of the current, which we already found in the first part, which is 0.667 multiplied by the value of the first battery. What is the value of the first battery? Which is 12 volt, and the value of the second battery is 4 volt, right? So here we are talking about the first battery. So 0.667 multiplied by 12. What's the answer? 0.667 multiplied by 12. I got 8.0 watt, right? So 8.0 watt. It is not 80, it is 8 point, right? So this is the answer for energy transfer rate in battery 1. So likewise, you have to find what is the energy transfer rate in battery 2. That means it's our fifth question, right? Energy transfer rate in battery 2. Again, I am going to deal with the same rule, P, which is equal to I multiply by EM of 2. So P is power, which is equal to current multiplied by the EMF of the second battery. The current we already found as 0.667, and the second EMF by the battery, the second EMF battery is 4 volts. So what is the value? I got 2.668. I can write this as 2.67. And what's the unit? Watt. So this is the answer for the fifth question. Now we have to go back to the sixth subdivision, small question. So what is given in the sixth part? In the sixth question, is energy being supplied or absorbed by battery 1 and battery 2? So you have to see this diagram. Here we have the positive terminal of the first battery, because the first battery is the strongest. So the current is flowing in this direction, right? Clear? And you can see the second battery. In the second battery, the current is coming this direction. Am I right? But which one is the strongest? We have to give the importance. So if you want to answer for the sixth question, you have to see the circuit diagram. So what is given in the circuit diagram? The positive terminal of the first battery is connected to the positive terminal of the second battery, right? Am I right or not? So if you connect like that, what will happen? The energy is supplied by battery 1, right? So if battery 1 is supplying the energy, means your battery 2 is absorbing the energy. So that is the answer. If the first battery positive terminal is connected to the second battery positive terminal, what will happen? The strongest battery is going to supply the energy, and the weakest battery is going to absorb the energy from battery 1. So that is the answer for our sixth question and the seventh question. So what's the answer? Better I can mention in this below our fifth question. So our sixth question is F part. All right. So energy is supplied. Which one is supplied? Your energy is supplied by first battery, right? That means the current is in same direction. That means your first battery is going to discharge. because it is giving the energy. And what's the answer for the last question? G part. The energy is observed. Which one is going to observe? The energy is observed by the second battery. Clear? So first battery is going to lose the energy and the second battery is going to gain the energy. That means your first battery is the supplier and your second battery is the observer. So this is a theory question. So if you want to answer the last two questions, you have to see the diagram, and also you have to deal about we already studied all these things in the theoretical class, right? So you have to use that knowledge here, right? So this is the answer for your sixth part and the seventh part. So for giving the answer for sixth and seventh part, you have to see the circuit diagram. Clear? Clear? That's it. So this is the answer for our last question. Thank you.